Hi, good afternoon, Dr. White. Today I will be presenting coagulation and flocculation. So in terms of the definition, the coagulation and flocculations are both combined process, which a coagulant is first added to the water to destabilize suspended particles, colloidal and soft-dissolved material. But actually how this works is because typically we use a positive charge coagulant, for example, iron salts or aluminum salts. And because a lot of organic matters are negative, so in that way you can destabilize the suspended material. Then a flocculation is the process by which that destabilized particles and precipitation products aggregate. So we have flux here. And so these flux, you can add a flocculant, so these flux make larger, and then you can remove the flux by gravity settling or mechanical separation. So basically allow some time for the flocculant to settle all the material. And the coagulation involves a rapid mix, so 2 minutes at most for the coagulant to react. And then the flocculation implies a really low speed and maybe for a larger time, like 20 minutes. And then the settling could be from 30 minutes to 1 hour. In terms of the chemical reactions, so we have basically, as I mentioned before, alum and ferric salts, and iron salts, I'm sorry. So this means that you are going to use the alum or the iron because they are positive. You also need in your reaction some source of bicarbonate. So you can also estimate how much of a carbonate to add to your solution. And then these are the typical reactions for alum, ferric sulfide, and ferric chloride, which are the most common coagulants based on the book that we're using for the class. This is also a great comparison in which I am trying to show what are the difference between using aluminum salts and iron salts, which is great. And in both cases, you form iron hydroxide or aluminum hydroxide. But the main important thing here is to mention that according to the salt you're planning to use, you have to adjust your pH. And this is very important because typically the the aluminum hydroxide are more stable under a kind of broader not broader, a kind of restricted pH, so they are more effective at acid pH. But the iron hydroxide or the iron salts are like you can be more flexible with the pH. So finally, the advantages for the coagulation and flocculation is that it's kind of simple, it's effective, especially if you're going to remove suspended solid and organic matter because you're using a positive coagulant and the organic matter typically has a negative charge. And also a great advantage for developing communities is that you are available to access to natural coagulants as the moringa seeds. But the disadvantages is that, especially for water that doesn't have a lot of alkalinity, is that you need to add alkalinity. And also if you are planning to use like iron chloride or aluminum sulfate, it somehow involves cost because of the chemicals. You also need a pH control, especially by using aluminum salts. So that's a disadvantage for me. If you're planning to incorporate this technology to a developing community, you will have to explain like the effectiveness and control of pH, which might be a bit hard. And then there's an issue with color, especially with iron salts. If you have a lot of iron and it's not like balanced with the bicarbonate source, then you have like remaining iron like as a cation in your solution, and the color is kind of yellow and orange. So it can be a disadvantage, like having a treated water with this color. That will be all for now. Thank you so much. And I will stop sharing.